A planet has an average absorbed incoming energy intensity over its entire. So this is, we've already reflected light. We've already accounted for the fact that pi r squared is absorbed and that it's spread out over 4 pi r squared. So we've done the albedo calculation. We've done the whole average over the Earth intensity, right? And so that's what we end up with, right? So let's see, what is and its upper atmosphere has an albedo of 0.33. So what is incident from space on the upper atmosphere? Okay, well, okay, so if this is being absorbed over the entire surface, right, we can go 295 watts per square meter, and we're going to multiply by 4 pi r squared. So this is spread out over the entire area of the sphere, right? Okay. And now we're going to figure out what is happening frontally. That is, what's coming from the sun. On the side toward the sun, there's only pi r squared, right? So we're going to take the 295 and multiply by 4, and we get 1180 watts per square meter gets through on the sunward side, okay? So again, what we did there was we said, okay, 295 watts per square meter is spread out over the whole planet on average. But the question is, what is actually coming from the sun on the frontal side, right? And this is what actually makes it through the atmosphere, okay, on the sunward side. So now we need to do another calculation because more than that is actually coming from the sun. Some is reflected, right? So we know that the intensity absorbed is equal to the intensity from the sun times 1 minus the albedo. Right? So we know that this is what's being absorbed frontally. Okay? And that's going to be the energy from the sun times 1 minus, what's our albedo? 0.33. So we're kind of working this problem backwards, right? Okay, so 1180 divided by left parenthesis, 1 minus 0.33, right parenthesis, 1761.19. So this is what comes from the sun, hits the upper atmosphere. This is what makes it through the atmosphere. Divided by 4, this is what's spread out all over the entire Earth, okay?